Hi everyone. In today's lesson we're going to talk about functions, graphically and algebraically. But before we can do that, we have to go over a few vocabulary words first. So first things first, relations. A relation is a set of ordered pairs or points. And the set of all x values is called the domain values or the input. And the set of all y values is called the range or the output values. So if I give you this relation is a set of ordered pairs, a set of points. State the domain and state the range. So remember, domain is the set of all x values. So simply, all we need are these x values. So we have 1, 3, 5, 9, and 9. Now you're going to notice that 9 repeats itself. So you don't actually have to say it twice, but you'll just say the domain is the set of numbers 1, 3, 5, and 9. And let's talk about the range now. The range is the set of all y values. So 2, 2, 7, 8, and 10. Again, the 2 repeats, so you only need to state it once. So we have 2, 7, 8, and 10. So again, range is the set of all y values, and domain is the set of all x values. Okay, next, what is a function and what is the vertical line test? A function is a relation or set of points where every x value is paired to exactly one y value. And if you have it in graph form, the graph of any function must pass what's called the vertical line test. And basically, what the vertical line test is if you were to draw any vertical line up and down through the graph that's given, if the line you draw hits the graph once, then it passes. If it hits the graph more than once, then it fails. So this is the key part right here. If it hits it more than once, then it fails. Okay, so let's look at the next examples. The first question says, are the following relations functions? And explain your reasoning and then state the domain and range. So we want to know, is this relation a function? So basically, what can help sometimes is if you draw what's called a mapping. So what we could do is put all of the x values in this bubble and all of the y values in this bubble. So if we kind of do like what we did before, we have an x value of 1, we have an x value of 3, 5, 9, and 9. I believe it's the exact same example. So we have an x value of 1, 3, 5, and 9. And then we have y values of 2, 7, 8, and 10. So 2, 7, 8, and 10. And we're going to draw what's called a mapping. So if we look at this ordered pair goes x is 1 and y is 2. So you're just going to draw an arrow from 1 to 2. Then the next one is from 3 to 2. So we go from 3 to 2. Then the next one is 5 to 7. So we're going to draw an arrow again from 5 to 7. Then we go from 9 to 8 and then 9 to 10. So 9 to 8 and then 9 to 10. So the question, or the definition rather, of a function is where every x value is paired to exactly one y value. So this x value of 1 goes to one y value. This 3 goes to one y value. This 5 goes to one y value. But look at here. See this 9? This 9 goes to 8, but it also goes to 10. So it's at this point where we're actually failing, because one x value of 9 cannot go to two separate y values. So the question is this a function? And the answer is no. And the answer is no because every x value is not paired with exactly one y. And the domain and range is literally, because this is the exact same example as this, I'm just going to copy what the domain is and what the range is. It's all of the x values for the domain, so 1, 3, 5, and 9. and the range values 2, 7, 8, and 10. Okay, so now that we tried that one, I'd actually like you to try number 2 on your own. So pause the video and then hit resume when you're ready for the answer. Okay, so first you probably wanted to draw a mapping. So we have a mapping of all the x's and a mapping of all the y's. So the x's are 1, 3, 5, 4, and 9. And the y values are 2, 7, 15, and 10. And you want to draw your arrows. So if I look at this first one, 1 goes to 2. So I'm going to follow that pattern. So 1 goes to 2, 3 goes to 2, 5 goes to 7, 4 goes to 15, and 9 goes to 10. So does this fall as a function? A function is a relation where every x goes to one y. So this x goes to one space, this x goes to one space, this x goes to one place. They all go to one place, so the answer is yes, this is a function. And the domain is the set of all x values. So my domain is 1, 3, 5, 4, and 9. Sometimes they prefer to put the domain in order. You don't have to do that, but I'm going to just for purposes of neatness. So we're going to do 1, 3, 4, 5, and then 9. Again, doesn't really matter too much. The range was our set of y values, so 2, 2, 7, 15, and 10. Again, try to put them in order. So the lowest one is 2, then 7, then 10, and then 15. And that is our range. Okay, so let's try a few graphically examples. So first things first, this is an absolute value function. Is this absolute value function a function? So to test if it's a function graphically, we want to draw a vertical line, any vertical line, through the function. We can draw one here, we can draw one here, we can draw one anywhere we want. Notice how this line only touches that graph at one spot. This line that I drew here touches the graph at that spot, and this line that I drew hits that graph at that one spot. So any line that I draw, it only hit once. Therefore, it passes what we call the vertical line test. So passes, we'll call VLT, vertical line test, because it only hits once. So only hits once. So the answer is yes, it is a function. Now the domain and range are a little bit more challenging. So the domain is how wide the graph is. So the domain is the set of all x values. So I want you to think when you see the word domain, think how wide the graph goes. And range is the set of all y values, so think how tall the graph is, or how high the graph goes, basically. So if you think about it, you see how this arrow goes on forever? The graph is going up forever, so that would actually be a tall marker. It goes up, but as I'm going up, aren't I also going wide? I'm going to the left, but I'm also going up. So I'm going forever to the left, and I'm also going forever to the right. So we're going from negative infinity to positive infinity. And the way that we write that is with two open brackets. These are called open parentheses or soft brackets. Negative infinity, comma, positive infinity. And when you're doing this notation, this is called interval notation. You always want to put the smaller number here, comma, the larger number. That's always the process. So let's try again. Let's do now the range. So the range is how tall does the graph go? Well, there is no graph down here below the x-axis, but there's graph from here up. So there's a graph from 0 to all the way up to infinity. So for the range, we're actually going to write 0 because that's for the smallest value, and then it ends at infinity. Now, there's something unique around the 0. The 0 is actually going to get what we call a hard bracket. And the reason why we get a hard bracket there is because it's an actual point on the graph. This is a point that makes up all of the points, right, on this curve. So right here is a point, so if it has a point, you get a hard bracket. The reason why infinity gets a soft bracket is because I can never actually reach infinity. There's always one more. So infinity is not going to be an exact point. It's a little abstract. All right, let's look at number 4. So here's number 4. It's a circle. I want to know, is it a function? So let's do the same thing as we did in number 3. Let's draw a vertical line, any vertical line. So I could draw this one, I could draw this one. I could even draw this one down here, which is tangent to it. So here it hits once, but this line hits the circle twice, and so does this line. So both lines hit twice, except for this one, right? This one over here hits once. So just because it passes here and fails here doesn't mean it's a function. So the answer is no, it's not a function. And it's not a function because we found this one spot that failed. Domain and range in this one is actually a little bit easier. Domain is, the circle is only as wide as from this point to this point. That's it. This is how wide it is. So let's just count over. We've got -1, -2, -3, -4, 1, 2, 3, and +4. So since they are actual points on the circle, right? This is a point on the circle. This is a point on the circle. We get hard brackets. So my domain is from -4 to +4. And then my range, we're going to use how tall the graph goes. So how low does it go to how high does it go? And this is where the range would be. So we are from this point down here to this point up here. And if it's a true circle, it should be 4 also. So 1, 2, 3, 4, 1, 2, 3, 4. So again, hard brackets, my range is from -4 to +4. Hard brackets around both. Awesome. All right, I'd like you to try number 5 on your own and then hit resume when you are ready for the answer. My suggestion is that you take a look at this graph. It's a parabola kind of sideways. This is the graph from here to here. And you can assume that it has arrows at the end and that this line is really not part of it. It's just the end of this box. So it's a sideways parabola going like this. All right. So like I said, try it on your own and then hit resume when you're ready for the answer. Okay, so is it a function? Definitely not, because if I draw this vertical line, it hits here and here. So the answer is definitely no, not a function. The domain, well, the graph starts from here and goes all the way to the right. So from 0 all the way to +infinity. So we will say the domain is from 0 to infinity. Infinity always gets a parenthesis because we never can reach it. And this is an actual point on the graph, therefore it's a hard bracket. And now the range is how tall the graph is. Well, this arrow, if we were to kind of continue it, just so that you can get a picture, see how it goes up, right? And this one's going down forever. So it's going up forever, down forever, right? I know we're going to the right here, but you kind of have to look. I'm going right, but I'm also going right and up. Here I'm going right, but I'm still also going down. So technically I'm going up to +infinity and down to -infinity. So my range is -infinity to +infinity, which is in fact all real numbers. That's another symbol. This is set notation for all real numbers. You may see me use that at some point. All right, I think that's enough for today. We will do the back page tomorrow, so just leave that blank for now. All right. Thanks. Have a great night.